Okay, this lecture video is going to be an example of secondary active transport. So remember, in this process, the first thing that happens is primary active transport is used to establish a gradient of solute A. And then the second process, passive transport of A down its gradient, drives the transport of B up its concentration gradient. And the example that we're going to look at is the absorption of glucose in intestinal epithelial cells. Okay, so this process is going to be symport with sodium. So symport means that we're having transport at the same time, and that transport is going in the same direction. So when you guys do your presentations, you should determine if your process is uniport, symport, or antiport. And the primary mechanism, the primary transport that happens in the beginning, takes place with the sodium-potassium ATPase. So that's going to be the transporter that's used to pump sodium out of the cell and establish that sodium gradient. And then in the second part of the active transport mechanism, we'll have glucose transport down the particular, its gradient. So we could sketch this out to show what it looks like. This is going to hopefully not be too horrible. So here's my piece of my intestine. So this is the intestine. So this is where all of our nutrients are. And here is an epithelial cell lining that intestine. And I'll tell you that outside the cell, it's more positive, and inside the cell, it's more negative. And we also have low sodium concentration inside the cell, and we have higher sodium concentration outside the cell. So we can add our first sodium-potassium transporter. This is going to be the primary active transport that's establishing this high and low sodium concentrations. So a lot of times we just represent that channel like this. So this is going to be my sodium-potassium antiporter. So this ATPase is going to pump sodium in one direction and potassium in the other direction. But what we care about right now is the sodium cations, because that's what's going to affect this particular secondary active transport mechanism. So this antiporter is pumping sodium cations out of the cell. Okay, that's primary active transport, because we're going and building up this high concentration of sodium outside the cell. So that's the first step. Okay, so that's the first step in the secondary active transport mechanism. That's establishing the sodium gradient. Then, in the second mechanism, this is going to be when sodium, along with glucose, is going to flow into the cell. So we've got, how do I want to show this? So now we've got these sodium cations that are going to flow in. And we said this is a symport mechanism. So at the same time, we've got glucose from the food that you just ate. I guess I just ate, since this is my intestine. It's coming in at the same time. So this part then, this is the sodium glucose symport. Okay, so we know that this was the primary active transport that started the process. This was the second step in our active transporter. So the sodium-potassium antiporter was building up the concentration of gradient of sodium, and then when that sodium cation flowed back down its gradient, glucose was brought in with it. That was the symport mechanism. Then later on, we could even add in another channel over here. Let's see if I've got another color. This is a very colorful cell. That's purple, even though you can't tell. Then you've got other glucose transporters that are working by passive diffusion to send glucose out and about. Okay, so with this mechanism, this secondary active transport, we can build up a concentration gradient of about 6,000 times more glucose inside the cell versus glucose outside the cell. And I'll have another lecture video to show you how we can do that calculation.